Hey guys, this is question MM078 of the Maths Methods Sharp and Study Guide. A bike track runs through the bush in the Yarra Valley. A bird's eye view of the track is shown below. So this is a bird's eye view of the track with a few different points on the map. So a river runs through the x-axis with bridges at M and N, allowing cyclists to cross the river. So we've got a bridge here at M and a bridge here at N, and this x-axis is a river. At O, there is a shallow point in the river where riders can stop to swim, here. At C, there is a car park where the track starts, up here. At B and C, there are rest stops where riders can stop and recharge. There is a great fishing spot at Z, which is connected to the rest stop at B by a dirt track running directly north. Now, just so you know, this here on your sheet will be A and B. So at A and B, there are rest stops, not B and C. So from C to N, the curve of the bike track is modeled by y equals 1 over 100 times ax to the power of 4 plus bx to the power of 3 plus cx to the power of 2, where a, b, and c are real numbers. All measurements in kilometers, so that's going to be important for later, for when we have to answer the questions. What we've got here is question A. The car park at point C is located at -5, 6. The gradient of the curve at C is -8.9, and the curve has a turning point at x equals 9, take root 977 over 8. From this information, write down 3 simultaneous equations for A, B, and C. Cool. So basically what we've got to do is use these 3 pieces of information to create simultaneous equations for A, B, and C. So let's start by writing down the original equations. The original equation. So we've got y equals 1 over 100 times ax to the power of 4 plus bx cubed plus cx squared. Awesome. And we know, let's start with this one, the car park at point C is located at -5, 6. So we know that the point -5, 6 lies on this graph, which means that we can plug that in to get our first equation. So our y value is 6. So -5, 6. We get 1 over 100 times a -5 to the power of 4 plus b -5 cubed plus c -5 squared, which ends up being 1 over 100, and 5 to the power of 4 is 625. So 625a plus, take away 125b. Plus 25c. And that's really our first equation. And we can simplify that down by timesing each side by 100. So we get 600 on this side, and that 1 on 100 gets cancelled out. 625a takes 125b plus 25c. And there is a common factor of 25 here, which means that we get 24 equals 25a take 5b plus c, and this is really our first equation here. So let's not worry about that one. This is our real first equation. So what we're trying to do is create 3 simultaneous equations, which we can then plug into our calculator to get an answer. So that's our first one. To find our second one, we have the gradient of the curve at C is -8.9, and that's our information that we need to use now. So if you haven't done the differentiation component of your unit, don't worry about this question, but for now, if you do, then let's go. We know that the gradient is equal to dy dx. So we know that dy dx is -8.9 at x equals -5, because we're talking about point C, which has an x value of x equals -5. Awesome. So what is dy dx? dy dx is 1 over 100, and then we take the 4 from the power, times it by the front, and take 1 off the power, which means we get 4ax cubed. And same again, we take the 3 to the front, plus 3bx, and we take 1 off the power, so that becomes a squared. And then we have plus 2cx to the power of 1, which is just 2cx. Plugging in the values -8.9 and x equals -5, we get -8.9 equals 1 over 100, 4a -5 cubed plus 3b -5 squared plus 2c times negative 5. If we times both sides by 100, we get negative 890 equals negative 125 times 4, which is negative 500, A, plus 3b times 25, which is 75b, take away 10c. Here we can divide both sides by c, which means that we get, sorry, not c, 10. So divide both sides by 10, we get negative 89 equals negative 50a plus 15 on 2b, take away c, and this is our second simultaneous equation. Then for our third, we know that we have a turning point at x equals 9, take root 977 over 8, which means that our derivative, or dy dx, is equal to 0 at x equals 9, take root 977 over 8. Awesome. Which means we know that our derivative, because we worked it out before, is 4ax cubed, 1 over 100, 4ax cubed, plus 3bx squared, plus 2cx. And at x equals this, our derivative equals 0. So 0 equals 1 over 100, 4a, 9 take root 977 over 8 cubed, plus 3b, 9 take root 977 over 8, plus 2c, 9 take root 977 over 8. Which seems like a pretty ridiculous sort of question, but these ones do come up in the exams. And this is the reason why you would need your calculator for this. But nevertheless, this is your third simultaneous equation, which means that we have our first one, which we wrote down before, our second one, and our third one, which we've got here, which means that that is our final answer for question AI. Part AII, hence show that A equals 2, B equals negative 6, and C equals negative 56. All we need to do is put in your simultaneous equations into your calculator. So basically we've got our first simultaneous equation, which is 24 equals 25a, take 5b plus c. Got our second one, which is equal to negative 89 equals negative 50a plus 15 on 2b, take c. And our third one, which is 0 equals 1 over 100, 4a, 9 take root 977 over 8 cubed, plus 3b, 9 take root 977 over 8 squared, plus 2c, that's 9 take root 977 over 8. These are our three simultaneous equations, and then all you've got to do is put them in your calculator. Make sure you don't make any errors, especially with this one here. And you would go into, I believe, menu 371, which is algebra, solve systems of equations, and then solve systems of equations, and simply put in three different variables, A, B, and C, and then solve for that, according to Kaz, which will actually give you A equals 2, B equals negative 6, and C equals negative 56. And that's our answer. That's it. Part BI, find, giving answers correct to 2 decimal places where necessary, the coordinates of M and N. Awesome. So according to our graph, M and N are our x-intercepts. So we have an x-intercept at M, O, and N, and all we've got to do is figure out the coordinates of those, and then we figure out the coordinates of M and N. So how do we figure out x-intercepts? So x-intercepts occur when y equals 0. And what's our original equation now? So we've got y equals 1 over 100 ax to the power of 4, where a is 2, so 2x to the power of 4, minus 6x cubed, take 56x squared. So that's all good. And all we've got to do is make y equals 0, and then solve for x. So we've got 0 equals 1 over 100, 2x to the power of 4, take 6x cubed, take 56x squared. Awesome. Dividing both sides by 1 over 100, we cancel that out. So that becomes 2x to the power of 4, take 6x cubed, take 56x squared. Now to factorize this. So our common factor here is 2x squared. So the coefficients all have a common factor of 2, and all the x's have a common factor of x squared. So we get a 2x squared out the front, and what we then do is we get x to the power of 2 minus 3x minus 28. Awesome. And this bit here is a easily factorizable quadratic trinomial. So what this becomes is x minus 7, x plus 4. Reason being is negative 7 times 4 is negative 28, and negative 7 plus 4 is negative 3. So then, because of our null factor law, 0 has to equal each one of these. So we get 0 equals 2x squared, 0 equals x takes 7, and 0 equals x plus 4, meaning that x equals 0, x equals 7, and x equals negative 4. Awesome. We know that m and n are not at x equals 0 because O is at x equals 0. M is on our negative side of the y-axis, which means that m occurs here, and n is on our positive side, which means it occurs at x equals positive 7. Which means, therefore, m equals negative 4, 0, and n equals 7, 0. Now we need to do this because the question is asked for the coordinates of m and n, not just their x values. So once we've come up with the x values, we actually need to make the coordinate that is sort of based off that. So this is your final answer. Part B, II. The distance cyclists, find the distance cyclists must ride on the dirt track to get from B to Z. So this is only 1 mark, which means you can do this whole thing in your calculator. So the easiest way to do this is to sketch this in your calculator. Simply put that in. You might need to put a times in between this, in between the bracket and the fraction, and that will sketch that. And you'll end up seeing this, and you'll see that the point B is this turning point down here, which is what you want to find. So the distance that the cyclist must ride on the dirt track is simply this distance here, which is also equal to the y value at B. So all you've got to do is sketch this graph on your calculator, find out where that turning point is. So you would trace the graph to that point, to the minimum, or you could go into the menu and find the minimum function, and that will tell you. So that would tell you the coordinates of that point, and then the y value of that would simply be the distance. So obviously you're going to get a, well, not obviously, when you do it, you're going to get 9 plus root 977 over 8 negative 9, or negative 9.00. I don't think it's exactly 9. Which means that your distance is going to be 9.00 kilometers. And we're doing that because the answer asks for corrected 2 decimal places where necessary, and it's not exactly 9, which means that we have to do 9.00, and the units is kilometers. So that's your 1 mark and final answer. Part B, III. Find the distance as the crow flies between C and O. So what that means is, if we have C and O here, as the crow flies means the direct distance, the shortest possible distance between those 2 points. So we know that C has a coordinate of negative 5, 6, which means that if we sort of redraw this as a triangle, O is here and C is here. This is the distance we want to find, and because this is as the crow flies, and we know that if C has a coordinate of negative 5, 6, then this distance here must be 5, and this distance here must be 6. And if we want to find out what this value here is, we simply use Pythagoras Theorem. So according to Pythag, a squared plus b squared equals c squared, which means that 6 squared plus 5 squared is equal to x squared, in this case, this x over here. Which means that x is equal to the square root of 6 squared plus 5 squared, which is 36 plus 25, which is equal to the square root of 61. And because of the question asking for 2 decimal places, this is equal to 7.81 kilometers. Don't forget the kilometers, don't forget the decimal places. And that's it. Part C. At point N, the bike track turns into a straight path defined by a linear function. That is, the whole track after N has the same gradient as the original path at point N. What is the linear equation that defines the new section of the bike track? So what this is saying is, now you won't have this section on the end on your copy. This was simply one of our draft copies that we're using for the solutions. So what this is saying is, at point N, this graph is going to continue in a linear fashion. It's never going to, it doesn't follow the quartic path. So what that's saying is we need to find the linear equation that determines what that graph is governed by, basically. So this is our key. The whole track after N has the same gradient as the original path at point N. So how do we find what the original gradient is at point N? We use our derivative. So we know that dy dx, actually let's rewrite the original equation first. So we've got y equals 1 over 100, 2x to the power of 4, take 6x cubed, take 56x squared, which means that dy dx is equal to 1 over 100, 4 times 2 is 8, and you take 1 off the power, 8x cubed, take away, 6 times 3 is 18, take 1 off the power, and 2 times 56 is 112, and take 1 off the power. We know that at point N, we have a 0.70, and we're trying to find out the gradient at that point. So our x value there is 7, so dy dx equals 1 over 100, 8 times 7 cubed, take away 18, times 7 squared, take 112 times 7, which is equal to 10.78. So, from here, we know that our gradient of our new function is 10.78. So a linear function always follows the curve y equals mx plus c, where m is our gradient and c is our y-intercept. So we now know what our sort of first look at our function is, I guess. And we know that there's, again, a point at 7, 0, and we know that our first graph is here, and x is 7, y is 0, which means we just sub these in, plus c, and what we get is 0 equals 75.46 plus c, which means c equals negative 75.46, and we have our equation. So we got y equals 10.78x, take away 75.46, and this is our final answer. Part C, II. What is the true bearing of the direction that cyclists are traveling once they are on this section of the path to the nearest degree? Cool, so what is a true bearing? A true bearing is the direction that a cyclist is traveling in relative to where north is. So basically, how many degrees off north are they? And that's what we need to figure out. So basically, we know that the cyclists travel up like this at a gradient of 10.78, which is what we worked out in the previous question. Which means that this, if we were to use this as a triangle, this triangle would have a gradient of 10.78. We know that gradient is equal to rise over run. So to make this triangle have a gradient of 10.78, what we actually need to do is have a rise of 10.78 and a run of 1, because 10.78 divided by 1 is 10.78, which gives us a gradient of the required 10.78. And what we're actually trying to do is, if this way is north, we're trying to find out the true bearing, which is this section here. But we can't figure that out until we know what this bit here is, x degrees. So let's work out what x degrees is, and then we'll be able to figure out what theta is. So from here, we know that tan x degrees is equal to 10.78 over 1. Opposite over adjacent. X degrees is equal to the inverse tan of 10.78, which gives us 84.7 degrees. Because north is perpendicular to the side of this triangle, which is at the x-axis, that means that this is a 90-degree angle here, which means that theta is equal to 90 minus 84.7, which gives us the final answer. Theta is equal to, well, the second final answer, I guess, is equal to 5.3 degrees. However, this is not how you write a true bearing. A true bearing is written 0.005 degrees because it's out of 360 and like for a full revolution, and it's in degrees, so we need to put the degree symbol in. So this is our final answer. Theta equals 0.005 degrees.